This is with a Dodson gear set at 1200 horse. Welcome back to the channel, everybody. We're continuing our series on incorporating OE strategies in standalones from stock ECUs and manufacturers that have stuff that we like. I thought I'd show you the highest horsepower stock turbo Evo on pump gas that I know of. This was really on 92 octane. It was a 2.4 liter with an electric water pump, a cylinder head that had a bunch of port work done into it, a dump, like everything you could possibly do to make the thing breathe. Low enough compression that I could run 29 pounds without knock. But as you can see, it was a quick spike and drop. Made peak power 5,500 and 24 pounds. It didn't really have time to knock. Plus it had a 4.5-inch intercooler, I think it was. Did have one problem. Really didn't make any power past 7,100. But it was a lot of fun. Sometimes I miss it. You guys saw the picture of it here recently. But I'll end up using this for the intro to one of the episodes. So let's get to the data. This is another Subaru OE strategy, and I've kind of modified it, but in the Subaru from the factory on cylinder 3 and 4, they pull 3 degrees, I believe it is, as soon as it gets in boost to try to pardon me, to try to keep the motor happy, not the movie. And in this situation, I started with some known values from another Subaru. Actually, when I did a video on for Omar in his car, it was on an Infinity, and he was generating not necessarily knock, but it was generating some ignition noise that I wasn't sure if it was knock. So I pulled timing. Didn't really seem to hurt power. So even though we were on ethanol, we were only 32 pounds of boost. It's hard to say exactly what it was doing, as it wasn't always consistent, but I went ahead and pulled timing. It disappeared. I left it out. So this is something I came up with for that application, which I think was S2s or S3 camshafts, built motor, high RPM, big turbo. He has a 6870. This particular Subaru that we're looking at the map for was a 6466. So lots of things making noise that, you know, who knows if it was truly knock, if it was engine noise, valve train noise, turbo noise, exhaust noise. But I left that OE strategy. Now, we've kind of covered that across the board in other videos on knock control, but there are some motors that just do that out of the gate. Subaru would be one of them. So if you want to keep your cylinder 3 and 4, or primarily cylinder 4 happy, pull a little timing, add a little fuel. You can do both of those strategies in the Subaru factory computer. So not necessarily a bad thing to do just if you're on a stock engine or a built engine, but you're really abusing it regularly. Obviously on the Subarus, the cylinder 4 cooling mod is a big help. But just because some of the inherent design of the exhaust ports and other things, we need to take that into account as we tune them and push them. So one other OE strategy that does work, it's easy to incorporate, and in this particular one, it's just as easy as going to corrections and turning on cylinder correction. Then you can have the choice of how you populate it. I did it boost versus RPM, really easy to do. This is an example of one that you could do versus transient throttle change instead of RPM. It's not conditional. So, you know, you kind of have to decide what strategy you want. Maybe you would do something like that and not use the generic correction that I call transient spark retard. You could set that up a couple different ways, really. So, you know, maybe as a road racer, that's what you want to do. If you're doing highway pulls or half mile, maybe you want to go more this way, where it's something easily tunable, and you can look at all those channels. So let's move to another strategy that I'm going to have set up as a generic map in this particular uh, series that is for Mitsubishi, and I like it. Some standalones actually do it natively. You actually have to change away from this. So let's switch to that, and it's on the subject of boost control. Briefly, I'm going to show you how I had it set up. Not that you would most likely do it this way. You would do it under your actual boost control strategy. But one of my tuning colleagues' friends wanted to run two 3-port solenoids. And so he was running some ideas by me, and I decided to just build the map. So this one, really easy, generic output. And I set it up for a max solenoid, which I know is going to be 33 hertz. You get to name it. The signal type in this case is duty cycle, just because we're going to think in duty cycle, not pulse width or anything else, and that I wanted a table. So when we open the map, the Evo 10 and I'm sure other cars have boost control versus throttle. AM Infinity is one that does that, I think, out of the gate. So you have drive-by-wire accelerator pedal position and RPM as an axis. It's very easy to do. I only had 2 for that, no 4D tuning on this particular one. And then I just threw in some values for placeholders that as I'm putting some throttle in it, 60% throttle, maybe I only want 21%. We're going to just pretend that that gives me X amount of boost. We'll say 15 pounds. So that if I'm road racing and I'm at a fixed percentage, the turbo isn't going nuts. I'm not going to get surge. It's really only trying to do what I want. You'd probably also do this with your closed loop boost target, would want to be versus throttle, so that you can match the two up and really be able to fine tune it that way. But then if I'm pinned, in this example, 49% would do whatever, probably if 21 was 15 pounds, 49% would probably be 25 or 6 for most applications, maybe a little bit less. But at any rate, Mitsubishi has employed this since 2008. It's something that I see every day when I'm doing stock ECU tuning, and it's a really easy way to set stuff up. Now, I'm going to diverge here. I don't have a log of it, so the time I would spend for that, I'm just going to mention that as we grow as tuners, whether you're working in a shop, you want to open a shop, or you're just an enthusiast at home, you're going to see tables that you run into on a stock ECU, because that's what this video is about, is OE strategies that you just get used to. And obviously I can't say what those are. Maybe you're used to seeing individual knock correction per cylinder because you have a Ford or a BMW. You're used to some sort of a torque model, whatever you're used to, and you've gotten good at tuning. That's the type of strategy that I encourage you to figure out how to replicate in a standalone. The main reason is that it'll make you a faster tuner. PID control, if you have those values, you can usually figure out what the OE was trying to say. That might be its own video, but when you look at the stock ECU, let's say you see values of a 13, 25, and a 1 for your proportional, integral, and derivative for the actual PID. Now, in some standalones, you might see 0.13, 0.28, and 0.1. Well, you know that the OE had those numbers in there for a reason on their factory boost control. That's a good starting point. Looking for clues is very important as you develop your strategy of using, Ford, Chevy, Mitsubishi, Subaru, Nissan, whomever you might be tuning, using their strategies to replicate in your standalone. Even though it got its own video, I kind of wanted to go back and show you how I had populated the boost error versus drive-by-wire tables. Um, and if you go through and look in the Haltech documentation, you can figure out which of the numbers, and then it turns that number into one of these um, letters. So there are various tables you can set up. So as it spools before the closed loop is active, you can kind of head some of that off at the pass. Maybe it's just starting because of how you have your closed loop settings. It hasn't hit the full target and really started doing anything because it's still under. This would be the one also off boost. You might set that all to 100. Closed loop active, just to prevent variation. You can see I went 100, 90, 80, 75, so on and so forth. There is a certain amount of delay that it will look at, and you can see this in logs. So then that one is more aggressive, and then when we get to overboost, that's the same in this particular example. But just kind of wanted to show you some of the variation that you could do. Not a whole lot of time that we need to spend on this, since the last video was 17 minutes of me talking about it nonstop, but just wanted to show a little bit of how it actually ended up getting populated. If that content is something that you like, please consider giving me a thumbs up. If you haven't subscribed already, please consider doing so. Definitely leave comments for positive, negative. Let me know where I can improve, what you guys want to see in the future. It just helps the channel, and it helps get you the content that you want. If possibly you have a friend or a community group that can benefit from content like this, please consider sharing it with them. Facebook, Instagram, wherever you want to go. Lastly, if you want notified as new content is added, simply click on the bell icon and YouTube will do that for you. Thanks again, guys. Take care.